Alright, welcome to my Demo 2 video. And for Demo 2, we're going to focus on Target 2A. And Target 2A is I can add and subtract with these four number bases. So the first one we're going to start off with is binary. So binary adding and subtracting is pretty simple. You just add and subtract those ones and zeros. So we're going to start off with our adding. So we got 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 1 is 1, and then 1 plus 1 is actually 0, 1, because 1 plus 1 is 2, but in order to do it with binary, we represent it with 10, which is actually 2. And we'll check our answers after I'm done subtracting for that one. So for subtraction, we just do the opposite of adding. So 1 minus 1 is 0. 1 minus 0 is 1. And then 0 minus 1, we cannot do that, so we have to borrow from this 1 over here. So basically take that away, kind of turn this 0 into a 10, which, like I said before, the representation of 2 is 10 in binary. So we're basically making it like 2 minus 1, which in turn will basically saying 2 minus 1 is 1, and then that 1 turns into a 0. So then 0 minus 0 is 0. And to check our work, to make sure we did the binary adding and subtracting right, we just convert these numbers into their decimal value. So we got 9 plus 14. And then the way to check this bottom, which we know the way that we check it is by saying, so 9 plus 14 is 23. Then to check our binary number, we got 1 plus 2 plus 4 plus 16. Then 16 plus 4 is 20, plus 2 is 22, plus 1 is 23. So we know we got this number correct right here on the bottom. And then for subtraction, we convert like we did before, which we get 11 and 5. And 11 minus 5 is 6, and we know our binary number down here is 2 plus 4, which equals 6. So we know that we did that right. So for hexadecimal is a little bit more complicated. You got to convert your letter values into their appropriate numbers. So we know that C is 12, and so 12 plus 3 is 15, which is F. B plus F, so I know B is 11, F is 15, which equals 26. But there is no representation of 26 in hexadecimal, so we have to subtract it by the base of 16, which we get 10. And we know the representation of 10 is A. And since we had to subtract, we have to add a 1 over here to 7 plus 1. So we got 1 plus 7 is 8, 8 plus 1 is 9, and then 2 plus 3 is 5. And then for subtracting, kind of just do the inverse of what we did with addition. So I know A and 2, so 10 minus 2 is 8. 3 minus 1 is 2. 7 minus C, so we take 7 minus 11, or sorry, 12. Do that, 12, which equals negative 5, but then we add 16 to it, which gives us 11. So that is B. Yeah, B. And then since we had to borrow, essentially, we're going to take this 4, turn it into a 3, and then we do 3 minus 11 equals negative 8, but then you add 16, and you get 8. So we get 8. And then octal is pretty simple, but we kind of do it a little bit differently. When we do adding, we cannot add, make sure our numbers do not add over 8. So we got 5 plus 2, which is 7. 3 plus 4 is 7. And 1 plus 6 is 7. So it looks like we got lucky there with the 777. So it's a good lucky day. And then with subtraction, We just got to make sure that we don't go over 8. So 7 minus 6 is 1. And then we borrow from over here and turn that into a 6. Then we change that, but we change this 0 to an 8. And then 5, or 8 minus 5 is 3. And then we got 6. And then we got decimal, which, basic adding and subtracting from elementary school. So we got 4, 14, 9. And then 17 is 8, 4, and 1. So, yeah.